Hello friends, in this section we will talk about relationship between coefficients and zeros of a polynomial. Remember, in one of the previous sections we discussed about finding zeros of linear polynomial just by making use of the coefficients. For any linear polynomial of the form ax plus b, 0 is given by minus b by a. This means if you are given any linear polynomial, for example 6x plus 2, how can you find 0 of this polynomial? I know that a here is 6 and b here is 2. So 0 would be minus b by a, and that is minus 2 by 6, which is equal to minus 1 by 3. It's as simple as that. We did not plot any graph, we did not solve any equation. All we did was made use of these coefficients to find 0 of this linear polynomial. So let's see if we can use similar relations for quadratic as well as cubic polynomials. Let's work out some algebra before we get to these relations. Consider the quadratic polynomial 2x squared minus 2x minus 12. This is the same example that we used to plot as well. We got zeros as x equal to minus 2 and x equal to 3. Let's confirm these results algebraically as well. So, how do we solve it? To find zeros of the polynomial algebraically, what we have to do is, we have to equate the polynomial to 0 and then solve for x. So, when we do that, we get p of x equals 2x squared minus 2x minus 12 equal to 0. So, how do we go about solving this? This is something that you have done in your previous grades. You need to factorize this expression. And how do you do that? You look at the middle term, that is minus 2x, and you have to split this middle term into two terms such that the sum of these terms is equal to minus 2x and the product of these two terms will be equal to minus 12 into 2x squared, that is minus 24x squared. So, can you think of two terms whose sum is minus 2x and product is minus 24x squared? When you think over it, you will get these two terms as minus 6x and plus 4x. So, you just need to substitute the middle term minus 2x as minus 6x plus 4x. By taking common terms and upon further solving as shown, we get the final result as x minus 3 into 2x plus 4 equal to 0. I can take 2 common out of 2x plus 4 and write this as 2 into x plus 2. 2 being a constant, I can say that x minus 3 and x plus 2 are factors of this polynomial. To find the zeros of the polynomial, we equate it to 0. Now when we do that, we can see that either x plus 2 has to be 0 or x minus 3 has to be 0, which means x is equal to minus 2 or x is equal to 3. So there you go, these are the zeros of the quadratic polynomial that we were talking about. In general, if x minus m and x minus n are factors of a quadratic polynomial, we can say that m and n will be zeros of that polynomial. The converse is also true. That is, if m and n are zeros of a quadratic polynomial, then we can say that x minus m and x minus n are factors of that quadratic polynomial. Now, I want you to observe the quadratic polynomial once again. 2x squared minus 2x minus 12. We factorize this as 2 into x plus 2 into x minus 3. In general, for any quadratic polynomial ax squared plus bx plus c, you can factorize this as k into x minus m into x minus n. So, if you expand the RHS, you will get k into x squared minus m plus n into x plus mn. Now, you have LHS and you have RHS. compare the coefficients of x square in LHS and RHS. When you do that, you will get the value of k as a. Similarly, if you compare the coefficients of x in LHS and RHS, you will get b equals minus k into m plus n. Now we know that k is equal to a. Substituting this, we can write m plus n is equal to minus b by a. That is, sum of zeros is given by minus b by a. Similarly, if you compare the constants on both the sides, you will get k into mn equals c. Substituting the value of k as a, you will get this as mn equals c by a. Now what is mn? Mn is nothing but the product of the zeros. So we can say product of zeros is equal to c by a. Similarly, for a cubic polynomial, we have learned that it can have at most 3 zeros, which means I can factorize the cubic polynomial as x minus m into x minus n into x minus p. Following the same process as we did for quadratic polynomials, we get the following results for cubic polynomials. Now, before you move on to the next section, I would encourage you to look at the following examples and solve these questions. Make sure to cross-check your answer with the solution provided in the video. If you have any doubts, please feel free to use the doubt section. We will be happy to help you.